Are you ready? Are you ready to perform some nomenclature on some wonderful alkene structures? And you're going to show it. You're going to win. That's right. You're a winner, and you're going to prove to me that you're a winner too, because you're going to be able to name every single one of these structures that I provide you as an example. And I won't even have to go through an explanation. I guarantee it. Just sit back and watch. All right, so let's do another example in nomenclature. So we'll start off with CH3 and CH, and then double bond, and then CH, and then another CH. We'll have a CH3 on top, and then a CH3 over to the right. Okay, so here you go. Here's a structure, an example of what you would see in an assignment or on a test, and I would say, name it. Go through the rules of nomenclature and name the structure. I mean, that's what the directions are going to tell you to do, right? So, why don't you pause the video, and why don't you try to name this first? And then when you name it, unpause me, and then we'll go through the explanation of it. So now's your chance. Now's your chance to prove to me that you know how to name this structure. So do it now. Okay, so maybe you did, maybe you didn't. I'm still going to go through the explanation of how to name it. So number one, we're going to find the longest carbon chain. But the chain has to include the double bond that we see, right? So I can't really do like a 1, 2, 3 to the right. I can't do that. It doesn't make sense anyway, because that's not the longest carbon chain no matter what. So let's go all the way across. I'll see a 1, a 2, a 3, a 4, and a 5. If I go across, that includes the double bond. And is there any other way that I can get longer than a 5? And the question's no, because if I do a 1, 2, 3, 4, and go up for 5, it's the same number. So I'll keep it simple, and I'll just go straight across. Keep in mind, it doesn't work this way every single time, but in this case it did. All right, so this is a 5-carbon main chain. So this is a pentene, not pentane shampoo. Is that the shampoo? Pantene. Pantene is the shampoo. So it's not Pantene, it's pentene. All right, so it's pretty close. We just have another A instead of an E there. But pentene is going to be the name. All right, so 5 carbons. Where's the double bond? That's something that you're going to have to tell me. You can't forget about that, right? So where is the double bond? I either have to start left or I start right-handed and try to give it the lowest number possible. So in order to do that, 1, 2, 3, 4, and 5, this will give me a carbon 2. I've got my first double bond, right? If I go right-handed to left, this is going to give me a 1, 2, and a 3. So that will give me a higher number. So I'm going to number left to right here. So this is a 2-pentene. And then I can't forget I have a group that's hanging off that I didn't circle, right? And this group is called the methyl group because there's 1 carbon that's there. So on carbon number 4, I have a methyl group. So 4-methyl 2-pentene. That's going to be the name to the structure. So hopefully you got that right. If you did, pause me. Hopefully you got it right. I'm sure that you did. And if not, just kind of fib and squib and say that you did anyway. All right, so we're going to do another example. Let's do another one a little bit more complicated. Let's go CH3 carbon. And then off of this carbon, let's do a CH2, CH3 that points up. And then let's do a double bond that's here. And then from that location, we'll do a CH, CH2, CH2, and a CH3, and we'll name that one. So try it again. Just trust me, right? I mean, there's no pressure here. You're not in an actual classroom. We're doing this through lecture videos. So just pause me and then attempt to name this structure. Please, just attempt to name it first. And then we'll see how close that you'll get, because then you'll start to figure out the problems that you're having in nomenclature and how to fix them, possibly. So give me a pause, take a minute or 2 minutes, try to name the structure, and then hit play one more time. All right, so maybe you did, maybe you didn't. But if you did, let's double check your answer. If you didn't, let's walk through the explanation of how to name it. So the question here is the longest carbon chain, and most of you are probably going to do like a 1, 2, 3, 4, 5, and a 6. If you did this, this is wrong. That's wrong. Can't do it. And the reason is because there's a longer carbon chain that's here. This is a time that they try to trick you. And the reason is if we had went up, we would have gotten 2 more carbons in that long chain. Look at that. So really the long chain is 1, 2, 3, 4, 5, 6, and 7. It's going to circle around this way because this will be the longest carbon chain that will include the double bond. And that's our very first rule that we have to do. Okay, so 7 carbons in total, which means that this is going to be a heptene because there is a double bond that is present in that chain. And I see that. It's right there. It's at carbon number 3. So we'll put a 3 out here in front. Now, why is that a 3? If I numbered from the right-hand side and went over and up, then this would have been a carbon 1, a carbon 2, a carbon 3, and a carbon 4. So on the 4th carbon, it would have been a double bond. That's a higher number, and I can't do that. Rules of Value Pack says, longest carbon chain, I identified it, that includes the double bond. Well, there it is. I circled it. And then it said number closest to the end with the double bond. So that way you can give it a lower group number. And that's exactly what I did, and that's why I started with number 1 up here at the top. All right, so at carbon number 3, I see that right there, I have this group that's hanging off of that carbon. And that group, hopefully you would have told me that this is a 3-methyl. So 3-methyl, 3-heptene is going to be the name of that structure. All right, so let's try another one, right? We're just going to do example after example, so that way you'll feel a little bit more familiar with them. And this time I'm going to kind of blend this for you, just so you can get used to seeing it. This is a CH3, and I'm going to go up and down and up and down and up. And then here I'll go down and I'll put the double bond right here. All right, so here on the ends, I'm just going to finish these off with CH3 groups. Sometimes I do that, sometimes I don't. Sometimes Blackboard will do it, sometimes it won't. Sometimes the test will show it, sometimes it won't. Other times it will be full-blown skeletal all the way across. You'll see no carbons, you'll see no hydrogens that are there. But here I've just kind of made them pretty on the ends, and I've just made it a little tidy, so that way you are familiar with this represents a blend of carbons and hydrogens and skeletals. All right, so that's what this is all about. So I need to find the longest carbon chain, and I need to find the longest carbon chain with the double bond. Then I need a number where that double bond's at, and then I need to name any substituents that are off the group. So once again, pause me, take a stab at this, see what you come up with, and then we'll do the explanation together. All right, so maybe you did an example, maybe you tried it. I hope that you did. I think that you learn more that way if you do. So we need to go through and we need to figure out what the longest carbon chain is going to be. All right, so if I start taking a look at the carbons, so here's my first one, which represents that one. Here's a second, there's a third, there's a fourth, there's a fifth, and there's a sixth if I go all the way across. All right, if I don't go all the way across, but I kind of curve down, it's still 6. Still 6. So 6 is going to be my longest carbon chain. So I'll just circle that like that. And then over here, I'll write hexene because I know there's a double bond that's present. Now I've got to figure out how do I number the carbons to give my double bond the lowest group number possible. So I'm going to do both routes for you just so that you can see that. Here is the number 1 carbon. Remember that dot represents that CH3. So there's my first, here's my second, there's my third, here's my fourth, there's my fifth, and there's my sixth. And then if I number it from the right-hand side to the left, I'll do that in a different color just so you can see the difference. So here is 1, there is 2, here is 3, there is 4, here is 5, and here is 6. All right, so if I start numbering from the left-hand double bond happens at carbon number 3, right? That's the first time that I see that double bond on that particular carbon, so that would be a 3-hexene. If I start from the right and go left, Then here's carbon 1, there's carbon 2, here's carbon 3. All right, so carbon 3 will also get the double bond. So this is a tie. It's a tie. If I go from left to right, I get a 3-hexene. If I go from right to left, I get a 3-hexene. So you're probably saying, hey, that's pretty good, because no matter how I number it, I'm going to get the correct answer. Well, partially. All right. And the reason that I say this is because there's another group on here. Now that we know this is a tie, and there's no difference in how we number it from left to right or right to left, we have to worry about this group that's hanging off of that chain, and we have to name it. Well, we know that that name is going to be called a methyl. Okay. But I need to figure out what number goes with the methyl. Well, because the double bond was a tie, we now look at other things that are involved in the structure. And it looks like this substituent is closer on this end. And we need to give these substituents lowest numbers possible too. I mean, if this was a tie that cancels each other out, I don't really use that as a judgment call on how I number the chain. So that means I really do need to start numbering over here to the right-hand side. Because my double bond was a tie, I then turn to my methyl group, and that helps me make the decision. So at carbon number 2, I'm going to get a methyl group. So 2-methyl 3-hexene is going to be the name of that structure. All right, so let's try another one. We'll go back, and this time I will do all skeletal all the way across. All right, so here's the first carbon. All right, and we'll go down and over to the left. We'll kind of crook it out to the right-hand side a little bit. Here's a double bond. And then I do that number. So there you go. So just like before, pause it. See if you can give me a name for this structure. And then we'll double check you once you do this. All right, so let's double check your answer. Let's see if you got this correct, and if not, where your problem was. Maybe you'll be able to figure out where your common problems are lying. Okay, so longest carbon chain that includes the double bond. This does not go straight across. As you can imagine, you can visually see that already. It's not going to start over here and go to the right-hand side. Okay, there's something else that's longer that's there. So my longest carbon chain here is going to be a 1, 2, 3, 4, 5, 6, and 7. There's no way that I can get a carbon chain that is greater than 7 in the structure. For that reason, this is going to be called a heptene. All right, so that's at least where I can start. Now I've got to figure out where the double bond is at. I forget about all the other groups because it's just a methyl group. That's all it is. So my double bond right now is the priority. I need to figure out how to get my double bond the lowest number possible. So how do we do this? Well, I write down both decisions. If I start from the left, this is going to be carbon 1, 2, 3, and 4. So this would be 4 carbons if I go from the left hand inward. If I go from the right hand inward, here is my first carbon, second carbon, and here is a third carbon. So that is going to be the best case scenario for my double bond. If I start right-handed, there's my first carbon, there's my second, there's my third, there's my fourth, here's 5, there's number 6, and there's number 7. That will give me the lowest number for the double bond that I have. All right, so 3-heptene is going to be the beginning name of this structure. And now I can't forget that I do have a group over here that is pointed out that I haven't taken into consideration yet. So that's a 1 carbon. That 1 carbon is called the methyl group, and I need to give it a number. Well, that's at carbon number 5. Based on my numbering, and I numbered all of them all the way through to keep it easy, that way I won't forget it. Number 5, I have a methyl group. So 5-methyl 3-heptene is going to be the answer to that compound's name. All right, so let's do another. Let's keep it going. You're on a roll, hopefully. You're getting used to this, I hope. So we'll just do it again. and we'll do this one. Okay, so just like before, pause it, name it, figure out what you can figure out, and then come back and we'll double check your answer. Okay, so maybe you pushed the play button again, or maybe you just waited out the awkward pause. Who knows what you did? But we'll go through and we'll name this structure. Okay, so just like before, I'll find the longest carbon chain, and then I'll kind of go in order of the IUPAC rules like we talked about. The longest carbon chain looks like it's going to include this whole snake here. All right, so there we go. Got a little sloppy in the structure, but that's okay. You know what I mean. And if I count the number of carbons, there's 1, 2, 3, 4, 5, and 6. So this is a hexene. All right, so that works. Now I've got to figure out left to right or right to left. How do I number this thing? Well, let's just start on the left-hand side. If I start here, that's carbon 1, and then carbon 2, and then carbon 3. So that would give me a 3 position if I start from that end. And on the right-hand side, if I started here, there's carbon 1, and then here's carbon 2, and that would be carbon 3. Well, it's a tie. Just like we've seen before, it's a tie. So there's really no rhyme or reason at this point of which one is preferred. They both would give me the same lower number. That same lower number is a 3 no matter how I number it. So maybe I need to look elsewhere in order to figure out which is the proper way to number this system. Well, I've got a group, don't I? I have a group that's right here. And that group is a 1 carbon that's understood to be there, and that is a methyl group. So, because I have a tie in the double bond numbering, I then look elsewhere to make that decision. I see a methyl group. The methyl group is closer to this end. It's not closer to the right-hand end. And because of that, that will default the rules and say, okay, 1, 2, 3, 4, 5, and 6. That is the way that you have to number the chain. Because hexene's a tie, but the name of the game is to give everything lower number when possible. And right now is when possible. So at carbon number 3, I have a methyl group. So 3-methyl, 3-hexene is going to be the name of that structure. All right, let's do another. Keep going. Keep going. You're winning. You're winning. All right, CH3, CH2, CH2, carbon, and then here, boing, we'll do a CH3 that points down. Here we have a double bond. We'll do a CH3, or CH, sorry, CH2, CH, boing, it goes down, CH3, and then CH3. I know you love my sound effects, don't you? It makes you pay attention. I hope, at least, I hope. All right, so now we've got to name this structure. We've got to figure out how to do this. It's the longest carbon chain that includes the double bond. So because it says that includes the double bond, I know that it has to include these 2 carbons right there. I mean, there's no way around it. If I go left-handed, 1, 2, 3 straight across, 1, 2, 3 down. So on this side, it doesn't really matter, and I'll just keep it simple, and I'll just go straight across. I'm going to get the same number. Over here to the right-hand side, this carbon, if I just go down, there's 1. If I go straight across, there's going to be 3 more. So that will give me my longest carbon chain, and that's right there. So I've just circled my longest carbon chain. Just another way of doing it, another way of looking at it. So now I have to go through and I have to figure out how to name this sucker. So just like before, put me on pause, try it, see what you get. Maybe you're improving. Maybe you get this one correct and you got all the other ones wrong. You don't know. So as we do these problems, you're learning more and more, and maybe, just maybe, there's going to be a point where you do put me on pause, if it hasn't happened already, and you name the structure the proper way. So put me on pause, give it a shot, and then push the play button when you're done. Okay, so now we're back. We need to figure out how to name this molecule. It's pretty large compared to some of the others, but just don't let that deceive you. It's as easy as the others, I think, right? Okay, so the longest carbon chain, 1, 2, 3, 4, 5, 6, 7, 8, that goes all the way across. So this is going to be an octene, E-N-E, octene. All right, so where does that double bond occur? That is my number one priority. It's the only thing that I look for right now. There's no other groups on here that's important. Not yet. I just focus on my double bond. Where is my lower group number? All right, so if I start from the left, this is carbon 1, this is carbon 2, that's carbon 3, and this would be carbon 4. If I start on the right-hand side, this would be carbon 1, there's carbon 2, there's carbon 3, and this also would be carbon 4. So no matter which way I go, this is going to be 4 as far as the double bond goes. 4-octene as of right now. So now here is where I begin to look at the other parts of the molecule and try to figure out, is the other part of the molecule going to determine which way I number? Sometimes it does and sometimes it doesn't. Well, does it do it in this case? Let's see. So I know it's 4-octene. Now the name of the game, I know that we've got this group and I know that we have this group that we have to name. These two are both methyl, so I know it's a dimethyl. Okay, so I'm going to go ahead and write that down. Dimethyl something. I know that. So I've got to figure out where the numbers go. Again, I give these lower number priorities whenever possible, and right now is whenever possible. My double bond was a tie. Therefore, it does not make the determination. It relies on the methyl groups in order to determine how it gets numbered. So if I go from left to right, this is my first carbon. There's 2, there's 3. This is a 4, 5, 6, and a 7. All right, so there is one option for me to go. Left to right, I get a 4 and a 7 for my methyl groups. If I go right to left, I'll just draw the numbers here. I get a 1, so this is a spot number 2, 3, 4, and a 5, 6, 7, and 8. Well, which one's lower, folks? Hopefully you can at least tell me that. Is the 4-7 the better option, or is the 2-5 the better option? And I hope that you would tell me the 2-5 is the better option. That gives me overall lower numbers whenever possible. The trick here, if you want to do this, I don't encourage it, but some people do and some people like it, add the two numbers together. 5 plus 2 is 7, right? 7 plus 4, well, already 7 plus anything. 7 plus 1 would be a higher number than a 5 and a 2. So if that's what you want to do, you can do it that way, but 2 and 5 is going to be a better option for me. So this is the way that I'm going to number the system. 1, 2, 3, 4, 5, 6, 7, and 8. So at carbon 4, I have my ene, and then at carbon 2 and at carbon 5, that is where my dimethyl is going to be located. So 2,5-dimethyl 4-octene. See, if you say that enough, I think you feel good about yourself. You can impress your buddies. You can impress your friends. Show them what you're learning and organic. I think they will be impressed. Or they might just make fun of you behind your back. Who knows? All right, so let's do another example. CH3, CH. This time, let's slap a bromine on it. All right, C double bond, C, CH3, CH2, and CH3. Name it. I'm going to pause it. I'll let you do what you need to do. Try to come up with a name, and we'll double check it. Okay, so we're back. Let's see if you came up with the correct name for this. I hope you at least attempted it, because I think that you'll learn more and you'll learn quicker and you'll get better grades if that's what you do. All right, so we need to figure out the longest carbon chain, and I think this one's going to be pretty easy. The longest carbon chain that includes the double bond, well, if I go down, that's just one carbon. So if I keep going across, I can get 2 more. So that's what I'll do. All right, so there's the longest carbon chain. If I count those number of carbons, in total, it doesn't really matter how I number yet. 1, 2, 3, 4, 5, and 6 in total. All right, so this is going to be a hexene, and I've got to figure out where. Where's the double bond? All right, so if I number from left to right, this is my first carbon, 2 and 3. Carbon 3, that would be my first occurrence of the double bond. And if I go right to left and I do this one as number 1, 2, 3, carbon 3, that would also be my double bond. So it really doesn't matter here as far as the double bond is concerned, because I'm going to get a 3 no matter which direction that I number from. So we'll put a 3 out here in front. I know that's going to be correct, but the other things on the molecule will help me determine which way I need to go with this. All right, so now I've got two groups, don't I? I have two groups. This one is called a methyl. We've seen that over and over. And the Br is going to be called bromo. So I at least can name those. So put those into the name and you get partial credit. I mean, don't leave anything off. So you're working toward the fully correct name, but you're getting the pieces as you go. So I know that B comes before M. There's no difference in the IUPAC rules. So I'm going to write down bromo first, and then I'll write down methyl. So I know that that's the order that they have to come in. I've just got to figure out the numbers that's applied to each one of them. So how do I number the system? The double bond is a tie. I look at the other groups to make that determination. How do I do this? Well, remember I said that methyls and ethyls and propyls, all of those are pretty common. They're nothing special. I mean, all of the main chain is carbons and hydrogens too. So there's nothing outstanding about a methyl group or an ethyl group or a propyl group and so forth. Bromo, though, is a halogen. Bromos and chloros and fluoros and iodos, they don't come around very often, do they? I mean, how many times have we seen an example with some of them? They've been there, but not as much as methyls and ethyls and propyls and stuff have. So whenever the halogens come around, we do like to pay special attention to them. And because of that, I would like to give the halogen the lower group number. If it's between the halogen and an alkyl group, the halogen I like to give a lower group number to whenever possible. Because of that, this is going to tell me that I need to number this way. So carbon number 2, I get a bromo group. And then on carbon number 4, I get a methyl group. And there is the numbering for the correct IUPAC name for this structure. 2-bromo, 4-methyl, 3-hexene. Now, let's say that you did not know that. Let's say that you did not know halogens came first. And let's say that you numbered closest to the right-hand side and went left. Okay, well, if you did that, this is 1, 2, 3, 4, 5, and 6. And you would end up with a 3 for the methyl group and a 5 for the bromo group. Folks, that's higher numbers. Here you gave me a 2 and a 4. Overall, that's a lower number. If you went the other way and you did not know that halogen really likes to be given preference, you would have ended up with a 3 and a 5. And that would have been a higher number anyway. So by default, you would have went left-handed to right-handed, I hope, because this would have told you that was the way to give the lowest number possible, even if these bromos and alkyl groups were considered a tie group. You still would have went left-handed to right-handed because overall it gave you the lower group numbers, and that is what this is all about. All right, unless we have a super special group on there that really determines the direction, and we'll see some of those. Right now we haven't made it to that point, but unless we see some of those, it's the lowest group number for as many as we can get. All right? Okay, so that's where I'm going to stop this video. In the next one, we will pick up with more examples. And what we'll do in the next one is something that looks like this. This is where we're going to pick up. So in the break, go through, try to name this structure, see what kind of name you can get me. And then when you play the next video, we'll start off with that example and we'll see if you got that name correct.